Hello everyone! In this video, we're going to learn about the velocity time graph. Are you ready? Let's go! Now there are two information that we can get from the velocity time graph. The first one is the acceleration, and we can get the acceleration from its gradient. The steeper the gradient, the higher the acceleration. Next information that we can get from the VT graph is the distance traveled and the displacement. Now distance is the total length traveled by an object, while displacement, the shortest path traveled from initial point to a final point. Let's take a look at this graph. The blue area under the graph is the total distance traveled to the right, while the red down here is the total distance traveled to the left. If you are to find the total distance traveled, we simply add up the total distance regardless direction. But if you are trying to find its displacement, we have to minus the displacement to the right with the displacement to the left. Hence, the total displacement is 42 meters. Now let's learn the gradient of the patterns in the VT graph, like this one. Here, I divide it into two major parts. The forward direction, which is the positive velocity, and the opposite direction, which is negative velocity. These two gradients are positive. It means that this object is speeding up or accelerating. But look at the second slope. It is steeper. It means that this object accelerates quickly. Suddenly, this object decided to move at constant velocity, giving us zero acceleration, hence flat slope. Then, this object starts to decrease its velocity until it stops. Notice that the gradient not only the steepest, meaning it is so rapid, but since the gradient is negative, while the velocity is still positive, because we are still in the positive section, it indicates that this object is decelerating. If you see here, another flat slope, but this time it is located on the x-axis. This indicates that the object stops. How do we know? It is at zero velocity. Right here. Right here. This is the value of zero velocity. Then, at this point, it starts to change its direction backwards or opposite direction. This slope right here indicates that this object starts to increase its velocity, but this time to the opposite direction. Then it decided to stay at constant velocity again for a few units of time. And finally, its velocity starts to decrease or decelerate and stops right here. How do we know? You see that the gradient is positive. i.e., the acceleration is positive while the velocity is negative. Hence, it's decelerating. So remember, if you find the positive slope, it is positive acceleration. If you find that the gradient is negative, it means that the acceleration is also negative. If the gradient is flat or horizontal line, it indicates that the velocity is constant, hence the acceleration is zero. And lastly, the steeper the slope, the greater the acceleration. That's all. Bye.